All right, we are live.
Welcome, lads and ladettes, to Ether Roundtable number 97, How the Jezzies Rediscovered the Celestial Sphere.
Thank you
Take
for
it away,
that.
Alan G.
Thank you for that awesome introduction. All right, so tonight we're going to be going over some video evidence recorded by Nicki Minaj. I'm just kidding. That would be super awesome. But we're going to be going over the historical timeline as told to us by various sources about the evolution of Chinese mythology or cosmology and their ability to navigate. So we're going to be going over their change in cosmology and celestial navigation and how those things changed in tandem with one another and how advanced they had gotten by the time the Jesuits had showed up in the 1600s. And we're going to look at the story that the Jesuits tell us about the Chinese and the state of astronomy and celestial navigation that the Chinese were in at that time. And we're going to compare and contrast the narratives and see which one of these things is true. And we're also going to take a look at how, or another way to derive your longitude based off of a flat Earth cosmology. Because the interesting thing here, according to the mainstream narrative, that it wasn't until when the Jezzies showed up in the 1600s did they give the Chinese the celestial sphere model and the terrestrial sphere model merger and allowed them to, join the rest of the civilized world in navigation by using their internationally standardized coordinate system. But we'll see how that we'll see if there's like another narrative there that undermines that though. So let's get into it now with the cosmology for the Chinese. So to start us off here, they originally had the Gai Tian model, or the Gai Tian model, sorry. And what this model was, there is a cosmological model. There wasn't really, as far as I could tell, there wasn't any navigational purposes or anything tied to it. But they were flat earthers, and they thought that the Earth was a flat square, and that there was a singular dome above us, and that the heavenly bodies were moving within that dome, and then the vast cosmos was outside of that, and the heavens was also
Are you screen sharing for us in Discord at least?
should be. Can you see that?
I don't, but maybe that's just
Yeah.
me. I'll
No,
double
I got
check
it.
my side.
You got it. Hold on, let me lower the quality. It might be a little too much. Try now. It's at 720p.
I mean, you could go full screen on that bad boy unless you need those notes or whatever. You're watching presenter mode over here in Canva.
I do need some
Yeah, sure.
nizotes.
Okay.
I do need a couple of notes.
I can
just
see
in
it now.
case.
It wasn't even appearing for me earlier. I'm very sorry. All on
No,
me.
no
I can
worries.
see it now.
I will let it slide this time, but next time, obviously, it comes out of your pension. All right. So this was their cosmological model here: the flat Earth, single dome above us, and the heavens were also flat above us as well. And then, so yeah, flat ground, flat heavens, and then it was like a dome above us or whatever that separated the cosmos from the rest of the Earth there. And then, so this was in 165 BC, leading up to the first century. But as the first century rolls around, we're going to see a complete cosmological change in their belief system and an advancement that goes in tandem with the ability to celestial navigate. So by the first and second centuries, the Chinese had produced an equatorial mounted armillary sphere. And this is extremely significant because what this does is this tracks the sidereal positions of the celestial bodies. It gives you, daily positions of where the bodies are going to be overhead and angles to them. And what the European version does, the ecliptic mount, tells you where the sun is going to be within each zodiac, and that's divided up into 30-degree sections. So it doesn't tell you the daily positions of the stars like the equatorial mount one does. It's divided up into 24 sections. So it represents the positions of the stars for the day, so that they're not related in any way, because it's kind of contextually told that, or we're going to find out that it's going to be retold as if they might have had contacts with the Greeks or something and made theirs. No, the Greek and European ones are ecliptic mouths, and they tell you they're divided, so they're divided completely different. They tell you different things. You don't use the other. You don't use one of those. You would only use one of those for like navigational purposes. So that's a huge advancement in there. And then they also changed their cosmological belief system. So with these new armillary spheres that they had here that are divided up into 360 degrees, breaking everything into 15-degree sections so that they could, map this, or show where the stars are out with the sky. They ended up adding observer tubes to these, not quite a telescope, right? But they had like a little tube that they could look through that would just show that section of sky, so they could literally predict, where the celestial bodies were going to be, and then line it up, and then, oh look, that's where it'll be at that time. So as they as they produced this and started incorporating the use of this in their astronomical writings and mapping stars and whatnot, they also changed their cosmological belief system to the Hun Tian model, which is the Earth in this cosmology is, instead of being a square, it's a round disc, and the heavens now are, instead of being flat, are round they're curved, because you see in a sphere with a limit of vision. So they conceptualized the limit of vision, which made the heavens curved instead of being flat, and the ground remained flat. And then what isn't noted here, but what's in the diagrams when you look at the Hun Tian model, is they say that there's a vapor layer here between the ground and the celestial bodies here. And they conceptualized a medium that held up the bodies. So the mediums were floating in this vapor. The word they use for it is vapor, but they were, when you look into what they were describing with it, it was a medium that the celestial bodies floated in, and that's what held them up. So when people are like, what do you think holds up the sun and moon on your flat Earth model? It's like, well, I don't know. Maybe there's a vapor layer medium that holds up the body. So anyway, that's just what they were putting forward, to have a coherent cosmological belief system, as well as, that would go in tandem with their navigational system, which they want them to be, cohesive and stuff, because you're going to use the one to navigate on the ground. So they should at least be related a little bit, right? Now, a key part of making the spherical vision thing was extremely important, because this allowed them to solve for equinoxes, or sunsets and sunrises on the equinoxes. That was a big part of why this cosmology didn't work and why they abandoned it in favor of this one. And it gave them, and also we're going to see that they knew about the 24-hour sun. Well, it's very likely that they knew about it. And this would also give them a chance to explain that, because what they're doing now is they're separating the physicality of the heavens as like, okay, the Earth's down here, the sky's up there, but they're 1-to-1. Well, now down here, they're not exactly 1-to-1. And so they can be, that allows them like more freedom to not be tied down to what the Jesuits are going to propose about why stars are no longer visible when they get low in the horizon, and why they get low in the horizon, right? So this was about the, this is coming out of the 1st and 2nd century here, when they redefined their cosmological model and also started producing armillary spheres. And with that, they had a series of astronomers that would come through about every 100 years that would completely revolutionize their astronomical uses. And a lot of that came through categorizing stars, how they would categorize them, like brightness, how they would attribute patterns to them. Because what they started doing was they started making observatories where they would have zenith mounts, well, not zenith mounts, they would have 2 vertical poles, and you would just stand between the poles and look up at your 90-degree, and you would just mark stars that would, transit you. And you would mark like, so suppose this star was like, bright orange or whatever. And then it was also, there was like 2 stars that were beneath it, and it kind of formed like a little triangle. So they would mark down like, this is what this star looks like. It's accompanied by 2 other stars. They would give like great detailed descriptions of these stars as they would transit. And they ended up tracking, 1,400 stars a night over their observatories. And they were just, meticulously categorizing them over the next, like 1,200 years or so. But like I said, every 100 years within that 1,200 years, another astronomer would come along that would be, that would give some significant advances in their work. So like, for example, one of them invented a water clock. And what that does is it drips water and at a certain rate, and then that turns cogs, and those cogs will display uh, little symbols uh, that tell you what time it is, right? So I'll give you an example here of the one that they put in one of their observatories that they made. So once they had the water clock going and they had the armillary spheres going, they made an automated armillary sphere that would track the positions of the bodies with respect to the water system going in here. So what we're looking at here are these diagrams here, and the finished product on the outside, this is a reproduction of it, is these statuettes here are on little cog wheels and they turn. So the top two represent the hours, the bottom two represent the quarter hours. So you would know, 24 you'd have a 24-hour clock and you had 15 minute segments for the quarter hours. And as these would turn to display, each figurine would represent 1 o'clock, 12 o'clock, etc. So as these would go through, you would just look at this to reference what time it was. And up here, the armillary sphere would also turn in correspondence with what time it was. So they had
That's awesome.
Dude, they made Stellarium, bro.
That is awesome.
And the first model of this came out in like the 800s. And then this was remade by Su Song in about the 1200s or 1100s. And that's where we get this final product here, where it was, they basically made mechanical Stellarium.
Well before all the other contemporary stuff. So well before 1300 means like from the earliest Rhumb line maps, they had this, so they knew what they were doing. Also, are there fairy Jesuits bringing gifts of globe to everyone on every slide in the corner here? Is that what I'm looking at?
Yes, that's exactly what we're looking at.
Okay.
Yes, nailed it. All right. So there was even a lad who invented this like mini Stellarium dome thing that you would get inside of, and then it had a little tube that you would look out, and whatever star was supposed to be there that you were, looking at based off of how you would orientate this based off of its bearings, that star would be in there. So you had your little mini sphere observatory, like planetarium thing. It was insane. These guys were crushing it in astronomy. And then this guy, whose name I'm going to butcher, so my apologies, but Yu Shojin, this guy, a big part of what they were doing too, especially leading up to this guy in the 1200s to 1300s, was redefining their calendar, making sure that it was on point. Because before you go to navigate, you got to get your calendar game on point, because the boys are going to be out at sea for a number of years. And if they're going to be out of sync with Beijing, then that doesn't help them. Then it becomes impossible to navigate or reference anything useful. So everyone has to have a cohesive calendar before they can go out exploring. Now, there were some early records of them doing some exploration in like the 900s to the 1100s, but they didn't really go very far. I mean, I guess going to Australia is pretty impressive, but they ended up going much further than just that. But before they could like go out on a big expedition like that, they had to get that synchronized calendar. So this guy Gu Shojin basically made a calendar that was equivalent to the calendar that was going to be reproposed to them in the 1600s by the Jesuits. It only differed from the Jesuit calendar, the Jesuit solar calendar, by 20 seconds per month. So they were completely on par and equivalent to what was necessary to do celestial navigation, not only locally and make maps and find things locally within that, but to start navigating out and finding their longitude at sea. And then we're going to get into how they define longitude and stuff, because they actually start going on sailing expeditions in the 1400s. But before we learn about how they do that, we're going to segue over to how they tracked longitude and latitude. So I don't have the slides for the I do. Sorry. Right here. So starting off with these gnoms. Now, a lot of people pronounce them nomins because the G is silent, but I don't believe in silent letters. If there's a letter in front of it, obviously it's there for a reason. No letter should go unwasted. So the gnoms, these Chinese they would have these giant structures here. And you see this trough that extends out here. Now, there would be a 40-meter pole at the top of this, and it would cast a shadow at sunrise and at sunset. And so throughout sunrise and sunset, and also at noon, because it's going to reach its zero shadow point, or like the lowest shadow point. So anyway, what they'll do is they'll mark out the maximum length at sunrise and the and then when it starts to hit the noon point, when it starts to go back to no shadow, they mark that. And then at sunrise or sunset, sorry, they mark the length, the maximum length on that every day. For years they did this. As all of this was going on from like the 1st century to the 1200s, they started doing this. And what they found was that not only do the shadow links change every day, but they change relative to your latitude. And then they also found that there's like a variation in them. So they came up with the equation of time and like the variation of like the expected, when it would be there. And then the when it was actually there, they took the difference of that and they came up with the equation of time, and they mapped out like they had corrections for everything, like the same kind of corrections that are now reproposed as like only possible due to XYZ globe mechanism here. Well, these guys, remember, they're cosmology, geocentric flat earthers that see in a hemisphere of vision. They don't care why an object isn't visible. They only care that, about what they can see. Everything else is in a, when they move, what they see will be available to them and they can go from there. So like as far as dynamic causes why it's gone, they're just like vision. Other than that, we don't care. As with just that as their basic principle and the earth being flat, they mapped out shadow tables for every day of the year and every latitude, because you can just calculate them out. So what they found was that every 100 kilometers there was a 2-inch variation in the maximum dimensions at sunrise and sunset. So moving forward, as a ratio of their 40-meter genomes back in Beijing, what they could do is send sailors out, send the lads out with 8-foot poles. They could measure the shadow links on the days, or sunrise and sunset on that, figure out their latitude and local time, because when the shadow reaches that midpoint, that's when it's going to be your local noon. So now, boom, you just discovered what time it is. Now you can synchronize your water clocks to that, so you can know what time it is at night. And then on top of that, this is what sets the stage. This baseline information of knowing their latitude based off of the shadows is what's going to allow them to determine their longitude later at night. But this is the baseline for setting up for how they went and mapped out the entire world. Because once you have these tables set, you can then reference them anywhere and go from there. Okay, so we got all the necessary information from the genomes. So now we need to apply it to eclipses. So we got star catalogs from stars transiting our observatories here. And then we have shadow links. So now we have a 0 longitude line because we marked where this star was. Because as we've been watching from our observatory that keeps time automatically for us, right? We've been marking stars when they transit our zenith and setting a 0 longitude point. So now when we go out anywhere in the world and we look up in the sky at our zenith, per a specific celestial phenomenon, namely a lunar eclipse, we can make a reference to what star that is and where it was with respect to Beijing, and we could subtract the difference of that, multiply it by 15, and get our longitude. And that's insane that they came up with that. So what? Go ahead.
Exactly what they do today, right? They just use their local time. They have a central comparison point, and in a modern system, the modern two-sphere model uses Greenwich at 0. So that's the point of them finding local time, so that you can compare it to Greenwich Mean Time to get your actual thing. So the Chinese were doing that well before the two-sphere model. That's super interesting.
Well before the two-sphere model. And all they did was just set Beijing as their 0 meridian. So everything was relative to that. And once they had their local time and identified a star above their dome, they could reference where that star was at Beijing, subtract it, and then they're good to go. But the important part of that we kind of glossed over was the celestial event that happens at the same time for everyone to tie them all together. So the important piece of this is once we've got our shadow information and we've determined our longitude and local time, We also are referencing our eclipse table, so we know when there's going to be an eclipse. We know where it's going to be, because while they were tracking the stars and all of that, they were also predicting out eclipses and figuring out all of that. So they had eclipse tables. They realized those happened in cycles, etc. And once they familiarized themselves with the old stick and shadow, I believe that's all you need to predict an eclipse, if I'm not mistaken, Shane, right? Is it a stick and a shadow, or is there an additional component? Do you need a
Yep.
little tether so you can put a ball at the end and play volleyball on it, or
According-
is that, or do you just need the stick?
Yeah, according to the professor at at the University of Mathematics who was going over it, you really only need a stick, shadow, and some time.
Awesome. So these guys were hella familiar with how to use a stick and a shadow. So they had eclipse tables too. So once you arrived at your destination, so let's say you're, off here and you're observing an eclipse, what the important part of the lunar eclipse that you're looking for is this U3 right here. This U3 is the exact moment that the moon emerges from the other side of the sun when it's blocked out. At that exact moment, you're looking up where you took your solar noon measurements. You're just looking straight up, and you're like, "Hey, what star is above me?" Oh, it's a twinkly blue star. It's kind of faint, and and there's two other stars next to it that make a triangle. Let me consult my star index here. Oh, it's this one. Okay, what time was this one recorded at Beijing? Oh, it transited at this time. What's my time here? Oh, I know my time because I took some shadow measurements, so I know my local noon time, and I started my water clock. Now I'm just going to subtract the difference and multiply by 15. And now I have my longitude. And this method was reproduced in the 2000s by a professor and a couple of people that were, on his team to help him. So they went to New Zealand, Melbourne, and Singapore, and Tahiti, and they all measured the eclipse. They all measured what stars were at their zenith on the eclipse, and then they referenced those with respect to where they were at on a Beijing transit, or at their time when they transited Beijing, and they subtract multiply by 15, and they came within 1.1 degree for Tahiti, 0.1 degrees for New Zealand, 0.1 for Melbourne, and they were dead on for Singapore. And what that comes out to, they were all like within 60 miles, essentially. So like Shalom was saying earlier, if you're navigating at sea and you're within eyesight of shore, like you're good to go. So like this is the fact that this is usable right now, and it reproduces what the Jesuits reproposed to them as the celestial sphere and terrestrial sphere mutually exclusive sphere Earth model, or contingent on the sphere Earth model being the representative of where we live, using the same kind of transformations and timing references to Greenwich Mean Time instead of Beijing. Nothing can really be said about whether or not using that system alone proves the shape of the Earth or not. But so to continue on here, so to back up, now we know how they were determining longitude, how they were determining latitude, how they could use that to map out places. So suppose you didn't know the Tahiti coordinates, New Zealand, Melbourne, or Singapore. Let's suppose these lads were from China and they just sailed out, and they just happened to be at these locations, and they knew there was an eclipse coming up. They had their shadow reference table. They did all that. They referenced everything out, calculated it. Well, when they returned back to Beijing, they could figure out the difference and then map everything out, and that would be the latitude and longitude. So you could map out that entire 8,000 mile span of sea, latitude and longitude, with just by doing that. All these people just created a latitude longitude grid for that, because it's all calculated anyway, and it's based off of a circle. So you could just like this is how they started to map out the world. But anyway, so just think about that for a second. Yeah, go ahead.
Dude, what's funny? I was going to interject real quick. Is that part of the lore for the globe? One of the fake Greeks, Eratosthenes, and also Herodotus, not Herodotus, Ptolemy, right? What they did when they created their graticule was they also mapped out all their known location, created their own quote longitude grid that was definitely a sphere, but had a 0 point through Rhodes. So their lore, when they tried to lie about the story, actually models after the real story. from the real people that they took it from, and they just changed the names of the innocent or whatever so they could steal it. Just inserted their people to back the same story. That's crazy.
Yeah, because it takes a team of people to do this. Like, you can't do this solo. And if I'm not mistaken, Ptolemy's book is like he just did this all on his own.
Yeah, well, he claims that he stole most of it from somebody else, but that everyone seems to be cool with it. But yeah, and then he mysteriously
Well,
knew 8,000 different locations.
Yeah, so it's
Yeah, it's like nearness of tier or something.
Yo, that's right. So yeah, so you can't just swoop out 8,000 locations. You need people to observe a celestial phenomenon and then go back and compare it to your 0 point. So the fact that they don't include any of that in the history, and the only thing that happened to survive the fire is just the necessary information to use the terrestrial and celestial sphere with no understanding of where it came from. It's like, that's preposterous, dude. And it has to be delivered in this heroic narrative of like a single dude did it, they often refer to them as like a polymath. They're like, this polymath did it, and it's just like, what does that mean? Oh, it just means he could do literally anything.
It's like, yeah, okay, I got it.
He was the smartest person that ever existed in any field of study that came about. He not only mastered it, but he probably developed it and then taught it to everybody else. It's like, oh, okay, all right. So
Who's that?
Go ahead.
Who's that math guy in that damn show? God, I forget. The math god turns into everything. Oh, hells can do anything. We just got to follow the math. The math predicts everything. Math is our reality. Whatever. Sorry.
Math lad.
Math lad.
Yeah. All right. So let's see here. So remember, they had this crazy good calendar. They had a way to determine longitude and then map it out, send it back to the Beijing lads. They had a way to map out everything exactly how it's been proposed to us now as this mutually exclusive terrestrial celestial sphere model. They already did all this. Now we're going to learn about their expedition a little bit here. But before we do that, we're going to learn about Anaximenes. And we're often told that the azimuthal dome of vision, your azimuthal grid, a limit of vision, et cetera, is something that flat earthers made up. Specifically, it's something that Shane stole and or made up. Could be both. But when we look into the history of these things and cosmology and celestial navigation and the relationship, well, even in the Greek times, they came up with a limit of vision that was, and you can look into Animexes cosmology, and what he described was a limit of vision that curved the heavens. The earth was flat. You would see like this. He was like, he argued with Aristotle a bunch about, the shape of the earth. And he was like, one of the arguments was, well, what about my tilt? And he was like, well, what if the flat earth was tilted and it was the same? Like, it's just kinematics. When you're looking at the sky, like the thing that they were concerned about proving geometrically was like having a reason why the stars weren't visible and relating it to that. But if you have a field of vision that does the same thing, then, long story short, all their arguments were equivalent, and a dome of vision, solved everything in terms of being able to describe celestial bodies and sunsets on the equinoxes. So now that this dome of vision and thing keeps popping up, and these people start developing ways to navigate based off of that, we're going to put it to the most extreme test. So in the 15th century here, our guy General Zheng He sets out on his 7th expedition for the emperor to go map out the world. And this turned out to be a 5-year journey before they came back, and it ends up being stricken from the records. We don't know why. Everything was lost, destroyed. There's a couple map fragments here and there, like the Malkun map, etc. We'll get into that a little bit. But basically, all you need to know is this dude was a famous explorer for the Chinese, and this expedition was stricken from the records. It's not well talked about, but there's evidence that it happened. So we're going to go over some of the historical references. Some of them are kind of anecdotal, but some of them are eyewitness first accounts, them saying, oh, look, anyway, to kind of corroborate that this took place in the first place. And we'll even reference some statues that were made to commemorate some of the places. And we'll get into all that. But what we see here is in order to present the globe as like mutually exclusive, you need to have 100% control of the narrative and make it seem like everyone else was lost and, bound to the, just landlocked. Right. And then it wasn't until the Jesuits came along with the celestial and terrestrial sphere and helped everyone out that they could start to navigate, because they realized that the earth was truly a globe. Even when you look into the history of these papers, you'll find that the authors are confused and talk about how they must have known the earth was a sphere at this point because of XYZ. And it's like, nah, they were hardcore geocentric flat earthers all the way until the Jesuits showed up and tried to, redefine them as, to re-educate them as like, we're introducing the globe here. You guys are wrong and backwards. But they can't be wrong and backwards and also have accurate star maps, determine their longitude to an accuracy of 60 miles using eclipses and references to Beijing as the zero longitude. Like, you can't do that if you're dead wrong and ass backwards and like technologically undeveloped. That doesn't make any sense. So this guy sets out in 1421 on his expedition here, and what the purpose was, they already mapped out the north pretty good, so they were going to map out the south. They needed to get a pole star for the south so that they could establish the same relationship that they had with Polaris. And then once they had that, they also needed to establish a way to reference the South Pole, which we'll get into how they did that as we continue. But those were the two primary objectives, because once they had those relationships, then they could go anywhere in the South, and it doesn't matter. They were referencing it all to Beijing at the 0 point. So it didn't matter what, again, assuming no shape of the earth, they're just like, well, I mean, their assumption of the earth was that it was flat. The sky was curved. The Jesuits come along and say the earth is curved, and that's what's producing it. So let's see here. So we'll get into their expedition here. So there were two statues that were erected to commemorate this, and they give inscriptions and talk about some little factoids from the expedition. One of them mentions how they visited 3,000 territories, and another one was about the number of people that went, or the number of ships. It was like 800 ships that went out on this expedition. And then there was the distance traveled or whatever turned out to be 100,000 li, which was their unit of measurement that they were using for their coordinate system. And that comes out to be 50,000 kilometers. It's almost like they're all a ratio of the same thing. That's super weird.
What?
That
li? Is a li just a Chinese meter, a ratio of the terrestrial meridian, but Chinese?
Yes, bro. So coming up with units of measurement to relate the shadow links to, they also measured the heavens using the gnomes, and or like the altitude of the heavens and stuff, and they came up with all these figures that are relatable to the terrestrial meridian now, suspiciously. But obviously, they couldn't possibly be true, because we know that the sun is truly 93 million miles, and all that kind of stuff. So they make it seem like these people were wrong, but they were using a unit of measurement that's internally consistent with their coordinate system. So if you were to tell them that the sun wasn't 80,000 li high, like how could you prove it? You know what I'm saying? You could only do that if you had a unit of measurement derived from a coordinate system, and you were doing the same thing and just relating it differently, which is exactly what happened. So they're no less correct than what we are now with the quote unquote established distances for everything, right? Because all of the distances for the heavenly bodies are established as a ratio of their periodicity in pi. That doesn't that doesn't have any physical meaning to it. That produces
a unit literally based on that and observation and the radius. Yeah,
it produces a number, but is it physically meaningful? Well, no. And if you want to do celestial navigation using the latitude longitude system as given to us by the Jezzies and the celestial and terrestrial sphere merger, well, you set the altitude to 39 and 59 when you do your transformation to the geocentric position for your reference of where the star once was on the first point of Aries. So, and that also maintains their 69 mile per degree relationship. So all of that's completely equivalent to also just multiplying out latitude lines by 90 giving 6210 for a physical elevation in units of measurement derived from the self-consistent coordinate system. So there's no difference in saying that they were 80,000 li, 6210 statute miles, or just an angle of 90. Like, it's they're all the same. Everyone gets a ride for free or whatever, as long as they're using the internally consistent coordinate system as their unit of measurement. All right. So anyway, well-documented statues at various locations that that commemorate this journey that hath been stricken from the record. All right. So let's see. And then we have some eyewitness testimony here from different accounts from some historical figures. There was a man named Ma Huan, and that guy wrote about how he saw their, these warships, basically, because their fleet that they went out with, they didn't just go out on like, oh, we're going fishing and we're bringing the boat, the boat that we take out to the lake. They took the fleet out. So they had all these warships at this port that they went to at Calicut. This was a really well-known and busy port. And so the fleet came out and was here for about 4 weeks and stocked up and everything. So anyway, this guy was telling a recounting of that. And there was also an account of an Italian adventurer who, Nicola di Pacella or something like that. He also gave an account of seeing the warships and stuff. And it's even hypothesized, and I throw a grain of salt on this or whatever, because this is just from the author of this book's the year the Chinese discovered the New World. This is just him kind of doing a little speculation here, but he hypothesizes that Italian guy, when he went back, because he was in exile for a little bit, and then to get forgiveness, he had to like tell the truth about his expedition or his voyages or whatever. And one of the things that he hypothesizes that he told them about the Chinese's ability to navigate and stuff, and because he would have been a likely candidate to like board their ships and stuff because of the business that guy was in. He was into like some trading stuff or whatever. So he thinks that guy hooked up with the Chinese, found out that they had badass maps and abilities to navigate, and then maybe even copied some of the maps but definitely reported on their technological abilities to the Pope and all that, which then would give the Europeans like, oh, we need to go to China and figure out what's going on over here, because they're advancing too quickly or whatever. So anyway,
that's why they got taken over from communism and suppressed so hard. That makes so much more sense. They were on it.
They were crushing too hard, bro. Like everything seems great right now. Like these guys are building a cohesive cosmological system. They're navigating, they're trading, they're out in the world, they're doing their thing. They sent out your boy to map the South. Guys, when you send people to map out the South, that's because you're done with the North. You finished it.
But when you reject the Jesuits, you get the War of 300 or whatever.
So everything was, like the official records and whatnot have been mostly destroyed. There's not a lot of records about this last voyage here, but we do have General He's maps. So one of the maps that's referenced is the Malkun map. You can Wikipedia that. Here's a little slice of it where they were just mapping out the coastlines of China and heading out to Lower Asia and all that. Like they were mapping out everything. And then there's some documentation here about how they were using the stars to navigate. Here's our familiar friend, the old Big Dipper, hanging out there. So this is them talking about how to use the stars to navigate. So these guys were literally pioneering this, in the early 900s to 1400s. Now this is a look at their expedition here. So they started in Beijing, came around down here, ended up to Calicut down in India, and then they went over to Africa, came down here through Satola, and then we'll look at what that looks like on the Peri Reis map. So once they got down here in South America, crossing over from Africa, the old Magellan Strait that we're told, the Spanish went Magellan and Earthball circumnavigate and all that. Okay, well, the Chinese went through it first, and then they actually told people what was like, what was, how to get through it safely, what to be expected and all that. And then on Magellan's journey, there was about to be a mutiny because they were running low on supplies and things were looking pretty dire. They had been out for a while, and they come to this strait. Magellan finally knows where he's at because the Chinese had already been there. They told everyone how to, what to expect, what's on the other side. So to quash the mutiny, Magellan was like, look, boys, we're exactly where we need to be. We're going to come out of this strait. Here's what's going to be on the other side. If what I say isn't on the other side, you guys can mutiny away, and it'll all be good. So they get through the other side. Everything is as is. He couldn't possibly have known what was on the other side unless he was, one, clairvoyant, or two, somebody else did it first and then told him about it. So you guys can decide which one of those you think is most likely to be true, but the Chinese did it first. And here we're looking at the Perry-Reese map that shows the exact same thing. And this map was actually constructed with information provided by the Chinese. And there was also another map that has a long name that starts with the W that I can't pronounce, that was made with completed with information from the Chinese here. So this was their attempt to go out south here. So when they got down here to the Falkland Islands, they were able to map out Canopus as their southern pole star because it has a 84 degree zenith to them, like it's 6 degrees off 90. So they were able to use that as their pole star there, and then they used Gamma Cruxus and Alpha Cruxus as the two stars that lead the Southern Cross that point to the South Pole. So using those two references, they were able to map out the rest of the South. And here's a look at their journey here. They ran into drift ice. You can see where they cut back down to lower Antarctica. So they went and mapped out the South. They accomplished their mission. They got their pole star down here. So once they have that, like I said, they can then go everywhere and do whatever, and nobody can tell them anything. So here's the stellarium view of them at the Falkland Islands using Canopus as their pole star relationship. I have its lowest point here. It gets as low as 14 degrees, but it gets as high as 84. It's a circumpolar star, so it never actually goes below the horizon or anything like that. It doesn't have negative quarties. It becomes circumpolar at like 52 degrees, I think it is, or something like that. So anyway, that's what they were using. This is what that's what their reference was. This is what the whole expedition was about. So mission accomplished. They had apparently been trying since the 900s. They had made a couple attempts to get the to get the South map so that they could start mapping it out. And that's it. And so as they were doing that expedition, they had the boys coming up on the shoreline, setting up their 8-foot gnomes, measuring their local time and latitude, and then using eclipses to determine their longitude, and then sending all that back to Beijing. And that's how they mapped out the entire world.
Did you have a thing of the shadow tables that they referenced, or was that just like
we don't have any documents of it or anything like that, but that's what the purpose of these were.
The nomens, that's probably really pronounced.
Yeah, the gnomes. The gnomes, yeah. Yeah. So in the 1600s, the Jesuits showed up, right? So this expedition was successful. That guy came back. They built commemorative statues. It was all good. And then all of a sudden they strike that from their record. No one's ever heard of it, never met her, except for all the corroborative evidence that tracks back to the expedition existing, etc.
Yeah, but then actually what happened was we found a story about a Jesuit guy called, some Greek who did all that, but different, and because Earth was a sphere. And also all the records of that are broken, and there was a fire, and we have this one book that references the other book, and it definitely happened. Trust us, bro. Wow, with that side of the story, our side makes a little bit more sense, I have to say.
So the Jezzies show up in the 1600s. Our boy Matteo Ricci comes in, and he's like, yo, your guys' calendar game is weak. Your guys' astronomical game is weak. We can help improve everything. Here's our calendar that we use. This is based off of the celestial terrestrial sphere model, et cetera, et cetera. Here's our here's our blah blah blah, and they were introducing this to, like, the way that they're retelling the story is like the Chinese were like stagnant and lost and didn't know what they were doing and just kind of like they actually
Barbarians,
they
pilgrims,
actually
Indian style, dude.
in some of the writings from the Jezzies, they go as far as to say that they didn't even know how to use the armillary spheres that were at their observatories. That's so
Yeah, they were
ridiculous.
building them. They were
That's
building
so-
them with sidereal
Bro.
time. They had no idea what they were doing. They didn't even know that you had to align it to the sun to use an armillary sphere. These stupid backward savages.
so insane, bro. To just like the ultimate gaslight on these people, because like they
Yep.
didn't just build one Ganam. Like they had specific locations that were specific distances apart for these. Like they were on point as you could be, and you know that's the case because in 2000, when they tried to reproduce what the Chinese did to map everything, it was exactly accurate to what the Jesuits are claiming that they reintroduced to the Chinese, as if they were lost without them.
That's funny. They did that everywhere. Then
They did it. So after this, so this was 1600s, and then they started this campaign in Japan in the 1800s. So they wrapped up here in the 1800s, went to Japan and was like, "Hey guys, did you know when the stars aren't visible, they're beneath your feet?" Because because all these people, all the Asian lads had the same cosmology. They were all geocentric flat earthers, and they all conceptualized so the Japanese, their cosmology was that the heavens are an illusion based off of optics, and you don't see the true heavens. Same exact concept of what the Chinese changed to when they were like, "Oh, this square 1-to-1 flat ratio doesn't exist. It's actually a disk and we see in a sphere." It's like they made the first stereographic projections, bro, of relating things to the ground. They had their own proof for Pythagoras' theorem. They had their own ability to make triangles and math out a triangle relationship and all that as a ratio. And the Jesuits come in and they're like, "Oh, have you heard of Pythagoras?" It's so insane.
Well, when was the Antikythera mechanism? That was like 2,000 years ago.
You can't measure the elevation to the heavens unless you already know how to Pythag theorem. Like just let that sink in. There's like they all measured the heavens and they're so inaccurate in measuring them. How'd they measure them in the first place? They never heard of Pythagoras' theorem. Well, they had their own triangle system. That's equivalent.
What about their mechanical time telling thing that you started with? Can you go back to that again?
Yeah, so they had these things called
water time,
called calypstras, and that's basically a water drip. There's different types of them, but you can think of it as like basically the flow of water will create a change in a gear that will change it at a certain ratio that will make little dials appear, and then you can read the dials to tell what time it is based off of how much the cog has moved.
That's awesome. That's awesome. I was trying to find comparisons to the Antikythera to be like with the mechanical turning gears. They emulated all of the sky and modeled stereographic projection, but then would do the ecliptic, the sidereal, so it would unite what both of those armillary spheres are showing in the Antikythera, right? Because it does sidereal and solar, in the phases of the moon, etc.
Dude, look at this. We're told that.
Look at that.
Check this out, bro. We're told that that the ecliptic armillary sphere is like the European/Greek, mutually exclusive one. Now we have the Chinese here who made the sidereal equatorial one, but they also had it says right here in 1437, pre-Jezzy, they had one that had all of them. It was adjustable, like it has different planes that you could rotate it on. So it had equatorial, ecliptic, horizontal coordinates, everything, all in one armillary sphere. That's preposterous.
They also made orreries after that, right? Which is like a model of the solar system using the same principle, and they model the ecliptic paths with like little circles that they spin. Not unlike what you'd have to make in elementary school to model the fake heliocentric system. That's just the 3D armillary sphere of a bigger area. So the principle is definitely sound.
Yeah.
I like how they think theirs is better and that you can't have one of sidereal time. Like the stars' time is useless. You got to align with the sun. That fits so well with all of their other, like, pagan mythology, sun worship, solar calendar, when everything has to be a leap year, complying with the seasons, ignoring everything else. Like
Dude,
all of that goes so deep and way back.
think about how crazy all that solar leap calendar 100 years, add one, forget to add one the next 100 so it's accurate for the next 300, subtract 3 divide by 4, like all that nonsense. They had a calendar that was the same equivalent. It only differed by 20 seconds.
Yeah, the Jesuits were big on everyone taking their sun calendar, dude. They were really pushing that hard. I'm curious, like, because the Asians seem to be like, nah, we're good, bro. We don't need you. And the Jesuits don't usually take kindly to that. Just think about all the countries that didn't have central banks in our time and what we did to them to spread democracy to them hard or whatever. So
Yeah.
what happens then with the history of China after then is like communists, dictators, and terror. I wonder if it's related to how hard they fought back with the initial sweep, right? The initial push forth
Yeah.
of the information.
Yeah, it must have been. Yeah, they must have really upset them, and then they took it out on them forever.
Yep, right away. Okay, you guys are first.
You guys are first. It's like, oh, you guys invented navigation. You're first.
No, we're gonna remove your history, replace it with ours, and then start from there. Yeah, that's what I think happened.
Yeah. Well, you know what's interesting too about the old history star swap was when I was reading Jeff Fomenko's work for the Chinese specifically. He said that they get like in the modern times when you look up, like they're like, this guy is our star catalog guy, and these are the stars he cataloged. And when you look them up, they have the same errors in
Tycho
gaps in
Brahe,
time.
tell me.
they have the same errors and gaps as they do as European history at the time.
No way.
So
I thought you were gonna tell me.
so they just so happen to have the same exact errors and missing stars. Like what? How could that be?
So they took Tycho Brahe and they were like, all right, so this is a guy called Tycho Brahe 2. He's not like the other Tycho Brahe, but he did discover all the same stars and made all the same mistakes in the same handwriting.
Yes.
I like it.
That is essentially what they did. Yeah, does anyone have any questions about any of this?
This was awesome.
Thank you. Yeah, it's extremely significant, man, because we're basically kind of like pigeonholed into like, you need to have an explanation for blah, 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 blah. It's like these guys explained everything and they could go anywhere and nobody could tell them, uh, anything, right? They derived everything exactly equivalent under their own cosmology. And it wasn't until it was subverted and retold as a mutually exclusive model that did the exact same thing under the exact same principles. The star, like it's a predictable cycle. Once you map out the hemisphere that you can see, anytime you can't see a star, you can always know when it'll come back if you know time. And guys, they one of the first things they figured out was how to make a clock with water.
I'm thinking though that if you don't have your own Gnomon tables with shadow links to get your latitude, that when the Jesuits came with their world spanning coordinate system, that hey, we can tell everywhere where you are, and you didn't already know how to get, say, to the southern extremes, what they were selling probably was much more palatable to other people, right?
Exactly.
That's crazy too.
Exactly, dude. And that's why the narrative has to be told through this like mutually exclusive, good-natured Jesuit fairies that went around sprinkling the globe everywhere because nobody could navigate or go anywhere until they went around and shared the globular influence with everyone. It's the most preposterous thing ever. And then we were just talking earlier, the Vikings used sunstones, so just a crystal that has biorefringence refractive properties in it, to where they could map out, or so that they could use that to find the sun when it was foggy or like under any visible conditions. Basically, they could figure out where the sun was at using this crystal and pointing it at the sky and looking through the clouds, because it would like be bright in a certain area. And with that, they navigated all over. Just using the sun for latitude. What's up?
No, nothing. I'm just here to hear Shane laugh. Yeah. But So if you travel like using their coordinate system, if you traveled east while looking south in the southern hemisphere, would the south celestial pool follow you around? Like, would it be like stay at the same
Yeah,
degree in the sky, but just simply move with you?
latitude dependent, similar to how Polaris would act, right? Exactly.
Yeah, yeah. That's why I think it's a reflection. But yeah,
I don't disagree.
good.
I have a question. Did in your research did you see any world, like you said they discovered the world? Did they have any world maps mapped out?
Yeah, so all we have are fragments of maps that are left over because, my Jesuit history has to produce their one final map by our boy Gerardus Mercator and obscure this Rumline map here. But yeah, this map here, this is called the Peri Reis map, and this map was just a Rumline sailing map. So basically, you sail here, get your bearing, sail here, figure out what your bearing is, or where you're going to go next, adjust to that bearing, sail there, and just keep doing that through this network of bearing adjustments. This map was finished and completed by the Chinese, helping map out the south information. And then, like I said, there was another map that I came across that started with a W, but like the fragments are so poor quality that it's like there's nothing to present on that. This one's the best one possible because you can clearly tell that's Antarctica. Like it's a pretty easy one to distinguish, but pretty much everything is lost from that period and there's not a lot left. And then what they end up representing, so that guy Matteo Ricci, who was working with the Chinese on subverting their culture or whatever, they ended up producing one of the first world maps, and it was like, but it's a quote unquote globe or whatever, because it's just using their latitude longitude as they're representing it as the terrestrial celestial sphere model. But
Mhm.
but they did produce one of those, but it's presented as the globe.
I think
Of course.
Yep.
I think that the maps were one of the things they targeted first when they were like, oh, so we're going to overwrite your history with our fake history where we did all the things that you did, but we're also going to destroy the maps that you made so that we can sell the world our map in 1600. Because when you look for like even the Rhumline maps on Wikipedia, they're all from supposedly the same period, which is hundreds of years after what you're saying. And then there's no maps before them. So like the map history goes from nothing, Rhumline globe. And it's like, oh, so we've only had these fragments of maps, and then all of a sudden everything was a globe. That's like what the history is. That's what's left of
Dude,
history.
all these
we'll
maps
tell
are
you.
just little tiny pieces of the globe.
Yeah, that's the story that they wanted to crack, right? They're like, look, they were doing it, but kind of, and because they didn't have the globe, they weren't very good at it, so we came along to help them. Exactly.
Yeah. Yeah,
Excellent, though. Excellent
wind
job.
rose and multi-degreed rums. Well said, Shalom. That is exactly it.
Also, I think I found the star that you were talking about that they named. It's this part of the Southern Cross, and it definitely is circumpolar. So it's like visible to everyone in southern latitude. Like if you're south of the equator, you can see this star wherever. So that makes sense when you're going to use it as the basis for navigation. It's just like Polaris, right in the north. If you get everyone can see it, then of course you can navigate with it. Makes perfect sense.
Absolutely. And then, so again, to like reiterate, right? Like, do you have to use, and so remember that whole thing about the chronometer? Like, oh, we got to get our chronometer. Otherwise,
Yep.
we can't do it. They had water chronometers. They can't even reference that those were used and that our boy replaced them with his pocket watch. Nope. They have to make it look like there was just no possible way to do it.
Yeah. If we had super precise droplet gear based timekeeping, then what would the story of the need for the chronometer really mean, dude? It's so funny. Obviously, we can't have that because we're gonna have our own savior. Can't have your solution. We got to create the problem and then have our solution.
No, they invented a method of timekeeping. They star cataloged and shadow cataloged latitude dependent observations so they could find where they're at, no matter where they're at.
That's the missing piece is a shadow reference so that there's a reliable way to tell local time. No one in non-Asian culture figured that out, it seems. We were
Yeah.
just running around, bumping into each other, sailing
Dude.
during the daytime, looking at the sun. And they
Dude.
weren't like, "Oh, you know what? We just need a table. We need to unite and take some data, fellas."
Dude, when I read it, I was like, oh my God, that's genius. Like that's
Yeah, it
so
really is.
because we're always posed the question like, how do you do, you replace it with your own? Ugh. And it's like, well, how would you do it? Well, you would need a way to determine time. It's like, no one's ever proposed a way to do that because it's a difficult thing. Like I would have never in a million years been like, okay, the shadows, right? That's crazy ingenious. And
Something.
then,
Well, you could never do it alone. You would need a buddy on the other side of the world, like whatever, comparing
Yeah.
shadow angles.
Yes. Yeah, they set up, dude, like that's the thing is like this was required such a concerted effort from everyone. Like it was uh the Chinese emperor in the first century, or no, I'm sorry, in the third century, took it as like a royal decree, or he said that, like God basically told him to make it of royal importance to get the calendar sorted out. So like they had, resources, funding, a whole team of people. Like this isn't like a bunch of dudes trying to figure it out for funsies. They were like educated and specifically trying to how to figure it out. They were paid. They,
Well,
they went and had jobs that were specifically to figure it out and to do it and to track it once they figured it out.
didn't they have
So it's like,
multiple observatories?
yes,
Right. So that would be precisely what the Jesuits were doing later with the Board of Longitude and actually the birthplace of Greenwich, where they placed an observatory 300 years before they named it Zero Prime Meridian. Why would they need to be precisely at that location, right? So multiple observatories in the south is definitely what you would need to do to map
Dude.
out the system. So,
dude. So
one for one.
So they pre-made that the 0 point and then mapped out ground positions on the first point of Aries to make it so that it's not relative to Beijing transits, but it's relative to where the object was on the spherical Earth at that time to tie it to the terrestrial. Wow, that is so ingenious. So they modified it slightly, but it's the same thing and it produces identical results.
Clearly they stole it, fudged it a little bit, reduced the history, and were like, guys, look what we did from forever. Look how it's always been.
Dude, that's so crazy. Oh,
Yep. Damn.
classic Jezzies. So yeah. So the importance of that, right? They created this whole thing of like, we're independently because they're tying all of so to tie them to the first point of Aries specifically, which is what was like the original Babylonian cosmology of how they did astronomy, but they didn't tie them to ground positions. They just knew where the stars would, like they tied it to zodiac positions. So to redo it under the same system to not make it relative to Beijing, they literally had to have like hundreds of people, thousands, make ground zenith measurements all over the earth every year until they had a table of where they were all at. And then they could go from there to make it relative to Greenwich. Just have that as the 0 time.
What year are we talking again? How early? How much earlier than 1600 is all this happening again? Is it 1100, 1200?
Okay, so they started popping off right out of the gate on the 1st century, bro. all the way leading up till the 1400s is when they did their big worldwide expedition. Had clearly mastered the north and was fixing on the south. They had already made southern attempts in the 900s.
So 200 BC is like Greek, Eratosthenes, Ptolemy, all them. So what do you think the odds are that Eratosthenes and Ptolemy are just really Chinese people who they renamed to tell the same story? Like, hey, that didn't happen, but it did happen. We did all that.
Yeah,
here's our guys.
it would. That seems very likely because the tools and mathematical things that they like derived, to like reference celestial and terrestrial relationships, came from the Chinese. They already did it, and then it's like these Greek guys also did it, but then everyone forgot.
Yeah, so it's everyone meet the real fake Greeks. When, when you have the fake Greeks on Wikipedia sourcing themselves, doing all the history, that creating all the fundamental
Yeah.
systems for heliocentricity. Well, no, it's actually these guys who did it the other way, but the Jesuits lied about the history and told you it was all for the globe, and then also told you always been 'tis globe.
Yeah.
Damn.
Oh yeah, yeah. Bogan just said that they also want to tell us that the Chinese had black powder 2,000 years for 2,000 years and only made fireworks with it. Didn't they have a rocket campaign or something too? I kind of remember watching a YouTube video about that because they had like some advanced rocketry / firework thing going on for their time as well.
Yeah, I was gonna say they're so advanced. It makes me think like, did they have any sort of flying or air stuff?
That would be awesome if they did.
What if Leonardo da Vinci is fake and also based on some nameless Asian dude who invented far cooler things?
just some Asian dude that was hella good at painting. And they were like, Michelangelo or whatever.
Well, the guy made inventions and flying machines and stuff. It was actually some Asian guy. Most of history actually was just some Asian guy.
Was just
who they
some
renamed.
Asian guy. Just a series of Asians that invented everything. Oh, man. That's crazy, though.
Yeah, it's pretty significant. This is awesome, Prezi. Thank you.
Yeah, it was my pleasure. It was a great information
Was
here,
this-
and it was fun. And it followed the Chinese or the Japanese stuff that I went over a couple weeks ago when we learned about the Western subjugation of the Japanese Buddhist cosmology.
Was this all because that one picture some dude posted in Telegram like 3 weeks ago?
Yes. Yep.
And then all directly or indirectly related to that picture meme led to a presentation and more research, a second presentation, and all of us putting more pieces together. Very cool. Very cool.
Shout out
You'll
to
have to post that.
shout out to Habitat Verderde. I just made
Love
that
that
name up,
dude.
but I said it so confidently that it could be it.
Yeah, no, I knew exactly who you meant. We've said it differently every time. If we said it the same, it'd be weird.
So yeah,
Habitat Verdad.
Verdad, yeah, Verdade, I think it is. I'll show you exactly what it was. Whoever that was that asked. I think it was Vamby. So it was this right here, this little device here. Somebody sent this link in Telegram, and I was like, "Ooh, I need to know what that is," because that looks like a bunch of azimuthal grids and celestial bodies that would be above, and then you would see how you would perceive said celestial bodies relative to your latitude. That was my immediate impression, and I was like, "There's no way that that's what it is." So after some Googling and about 6 hours of research, it's exactly what it is to the T, and it was specifically made to refute heliocentrism and the ball Earth claims.
Nice.
Oops.
Yeah, that was a good Prezi too. I caught that one as well.
Oh, nice. Yeah. Yep, it was exactly related. Hey, look, here they are drawing a triangle to the heavens. You can't do that. Only Pythagoras and his theorem can do that. All right.
Dude, the little gnome fairy Jesuits bringing globe happiness in form of fairy dust. Everyone really got me. I like how they were all over the place, and you made like so many different ones.
Sam made some of these. He used his AI to make some.
Nice.
It was a group effort to make all these Jesuits to contextually recreate history. It took all of us. So shout out to the lads. These ones are my favorite because they're very scholarly. They look very trustworthy.
You should go over the thumbnail context now, since everyone has the background to understand what we're looking at.
Right. So now that everyone knows what's going on here, right? We have the Emperor of China. He's got his calendar made by Gu Shinji. And he's like, look, this calendar is only 28 seconds different from your Jesuit calendar. You're telling me I need a new calendar? It doesn't make any sense. And the Jesuit's spinning the ball on his finger like you do with a basketball. You know, he's spinning his little globe, and he's like, but look at this globe terrestrial sphere model. This is how you get the real calendar. You want that 20 seconds, my dude, or what? You want to be off all the time? You living in the past? And as the Chinese emperor is like trying to figure out if this dude's serious or not, his boy, the Jesuits' boys are sneaking out the back with the Rhumb line map that they just got from their 14th century or 15th century expedition. Meanwhile, Nicki Minaj is over here in a time bubble. She's recording all the events and she's yelling, "Drop that map, Jezzies." But she can't physically interact with anyone in this timeline because that would violate Einstein-Minkowski's light cone, and you can't violate causality because that would mean Einstein's wrong.
Oh wow!
So
And then
time traveling Nikki can do nothing to actually warn the emperor of the great deceptions about to be played on his people. So she just yells helplessly and records.
Are the two people stealing the map also Jesuits, or are they affiliated with the court in the first place?
Oh, they are Jesuits. The only reason they got in here, the only reason they were even able to get in here is because this one teaches mathematics and this one teaches how to use those mathematics to navigate. So the emperor was like, I'll hear you out since you're, but like we can compare calendars, but like mine's like, do I need to upgrade? Is it necessary? And he's like, but the globe's shiny.
He's like, you don't see this globe? Maybe you're not looking at it hard enough. Could you look at it harder? Wow, man, the history makes so much more sense to me now. Like to put other countries in perspective. No wonder why they keep us so isolated and fighting each other so that we don't learn, Chinese history, because God forbid everyone puts the pieces together like, wait, did you guys have an Eratosthenes? Like, Eratosthenes? Who the hell is that? No, we had this Asian guy who did all the same things that your guy did. Wait, what? Yeah, is there a French guy also named Eratosthenes? Like, we should go find out. They'll be like, okay, hold on. Maybe there's a pattern here, fellas.
Yeah. Yeah, but some additional interesting information came out of this, though, so we can also get into the Greeks. There'll be a whole prezi on that. So I found a lot of, I forget what they call them, a doxographia, which is basically like the, what would you call it? Like the writings, like the argument writings of, like the back and forth between them or whatever, between the ancient Greeks, like the philosophers. So there's this doxographia I came across that has like the flat earth versus globe earth arguments between Anaximenes, Athenagoras, or whatever his name is, and Aristotle. So we can do a nice little prezi on their arguments and how they hold up now. Because spoiler alert, guys, the arguments that the Greeks were putting forward weren't super great. They didn't, but what's interesting though is they didn't even try to use ships going over the horizon when they were arguing with like other Greeks that knew, because if you argued perspective, it was immediately equivalent and it got nowhere. So when they got into like the big debate with them, that wasn't even brought up. They tried to just use sky stuff, like, but by eclipse makes a sphere or a shadow.
Oh wow!
Yeah, like literal bottom of the barrel tier.
I'd love to see that. Yeah.
I'd like to see it too, because I don't know if I'm doubting all of Greek and Roman history now, especially all the Socrates, Plato, Ptolemy, Eratosthenes, Hipparchus, and all of them. I'm doubting all of them together now, because they all take place at the same time as the people who were doing all the same shit over in China. Nobody knows anything about it. So all the dates are the same and all the stuff is the same, and I'm just like, I always kind of doubted that they were fake, but I didn't realize that they were all like based on true events, but tilted.
Yeah,
we'll just adjust it slightly. It's easier to think that they made it all up to have it equal, easily everything that they needed to show when they needed to show it, and it's like, no. Now I see how they just adapted it. Matter of fact, people born of jealousy were like, you can get everywhere already. You said. With shadow tables? Oh, well, what we need is sun tables. And based on the sun, we'll do the same thing you did. And now, you know what? Remove the bottom and presto, it's because Earth's a globe, couldn't be any other way.
Yeah. That's exactly it. Yeah, and when when they eventually got the Chinese to like start accepting the Tycho Brahe model, because they started with Tycho Brahe before they swooped in with Kepler and the boys to get them the Newtonian dynamics and stuff and move on to
Yep,
heliocentrism.
empirical observations.
To get them to start with that, apparently the Chinese didn't even care about the celestial motion, like them being in motion or the motion being relative, going around us stationary. They were like, we don't care. We just does it calculate or not? Great. Okay. Great. We're
Yep.
heliocentrists now. They didn't care at all.
Yeah,
According-
but what about refraction?
Exactly.
Nice. You want to wrap it up soon?
Yeah,
That was a
yeah,
good, nice
yeah.
long one.
Yeah, I think we can wrap it up on that. All right. Well, we'll see you guys. What do we got coming up tomorrow? Ooh, tomorrow we have the very first premiere debut of Flat Earth Gang on Discord. Shane's going to be doing his Prezi on negative coordinates. So the exact crux of the issue right now that we're dealing with, where do the stars go when they're not visible? Are they beneath thy feet, or are they out of your field of vision? Are they circling above you just out of your field, or are they physically beneath you? Now you can mathematically represent these things the same way, and a lot of the modern tools now that are presented in a way that makes it seem like they favor a globe mutually exclusively allow us to track stars, any time of day, etc. Similarly to how the Chinese did with their armillary sphere water clock. It gives the impression of like, oh, well, if the star is beneath your feet and I know where it's at, that must mean that it's a ball. That's obviously insane. And Shane's going to be going over a presentation with some awesome visuals to show the equivalence between the two coordinate systems, just mapping negative functions to when you can't see something because it's beneath your feet versus you can't see it because it's out of your field of vision and it's just physically circling above you. So that'll be an awesome presentation. We'll be going over that on Flat Earth Gang. Tune into that tomorrow at 8 p.m. Eastern. And then, of course, you can join the Flat Earth Gang on the Clubhouse app on your respective Android or iPhone device. And then on Friday, we will probably have a little community Twitter soiree. I think we missed it last week. And then Sunday, of course, will be Globebusters. We'll be going over the Jezzy Prezi once again. We'll learn all about the history of Nicki Minaj recording the Bad Man, and we'll go over the video files and see what we have. Maybe I'll represent this as historical archive footage from Nicki Minaj's videotape of this heist that happened. I call the heist Ocean's 1. It's the original heist. You can see this one's George Clooney, this one's Matt Damon, and this one's whoever else is in the movie, Jason Momoa, I assume, or something. All right. Very cool.